All right. Hello, everyone. Today we are going to finish the rest of the 1-2 notes, the three strategic themes. Just as a really, really quick recap, we have the three strategic themes, which, if you recall, were part of creating a sustainable future. Right, the three strategic themes were the ideas, sort of like the ideas driving all of it, leading to the integrative themes, which were the actions, and the combination of those two eventually leading to the goal of a sustainable future. Okay, we've talked about sustainability and stewardship. Right, sustainability, the ability to continue the processes and functions that we currently have in everyday life now without depleting any of the natural resources we need to keep it running. Stewardship, creating a certain ethical and moral framework that will educate our public and private actions and our actions in relationship to the environment and use of it and things like that. And then science, the third one that we've been working on, using logical processes to gain information necessary for us humans to improve our welfare and promote the health of the natural systems that support our lives. And we were working through science. We had talked about controversies in science and that information. Today is going to be a relatively short. I just wanted to finish up with the evaluating science. So your generation lives in a somewhat unique time. And I don't mean that in terms of necessarily what's going on. I mean that in terms of you have access through the internet and digital storage of information and whatnot. You have access to more knowledge at your fingertips than at any other point in human history. All right. You probably, if your parents or grandparents were taught, back in my day, we had to, we're doing research for a paper. We actually had to go to the library and check out books and look at these things called encyclopedias for information and stuff, And now you guys have access right at your fingertips to, essentially anything you could need to look up or find. So getting access to information isn't an issue, isn't really a difficulty at this point in time for you guys and moving forward. So what is your challenge? Well, your challenge with access to all of this massive amount of information now, your challenge is sifting through it and determining what is true and what is not, and what is valid and reliable and what is not. Because along with access to all kinds of information, there's also the access for people to essentially to find almost anything on any topic. And so for example, if you type a search, if you type something into a search engine, you can actually, if you ask it a leading question, you'll almost always find something there that says, that agrees with what you're saying. So for example, if you typed in, say, I'm trying to think, like, do vaccines cause autism? You're going to find a ton of information, I'll say information, ton of information on both sides. And if you typed in instead of do, if you just typed in vaccines cause autism, you're going to find a bunch of information that says vaccines cause autism. It's sort of like it's kind of a bad analogy, but like a self-fulfilling prophecy. When you type it in there, there's so much stuff out there, and people will put and people have the ability to put anything they want up on the internet. So you have to actually be careful about how you search for information, and then when you get information, analyzing it. So that's your challenge. Now, in terms of science, how do we determine what is sound science or what is junk science? Okay, now, so let's evaluate. I'm going to actually skip forward a little and come back to this. The other last two definitions on the third page here: junk science and sound science. So let's understand those before we talk about evaluating it. Junk science is information or ideas passed off as being scientific fact, but are actually based on little to no valid scientific data. Okay. Whereas sound science is information that has been well tested and has a reasonable amount of valid scientific data backing it up. So how do you know the difference? I'm going to show you, let me see if I can pull it up here. Search for it. There's, just for example, there it is. Okay, so a while back, this is several years ago now, probably 10 years ago. Um, I was watching TV kind of late at night, and one of those. I don't think it was as seen on TV ad, but it was one of those ads late at night that's like, and this ad for these Kinoki foot pads popped up, and essentially what the claim for these foot pads is that they're detoxing pads where you put them on your feet and before you go to bed, and when you wake up, you take them out, and the pads uh, absorb, like, pull toxins out of your body through your feet. Excuse me. They're advertising for these, and one of the people doing the commercial or whatever says something along the lines of the foot pad pulls, draws toxins from your body out your feet, similar to the way in which a tree roots, something about similar in the way to which tree roots like expel waste from a tree or something like that. I'm staring at the TV thinking to myself, they literally just compared people's feet to tree roots. Like that, that's true on no level, not even a level of an analogy. Like it's not even, that's not even accurate. Any part of it's not accurate. These are a total scam. And it bothered me so much. Obviously, I still remember it. And it bothered me too because they actually, at one point, these were sold in like Walgreens and stuff. And um, it just bothered me, like people making these claims that are total junk science on TV. And I'm thinking, like, yeah, people are actually probably buying this and thinking, and and then the other half of me thinks, well, if you're dumb enough to actually believe that's true, then maybe you deserve to be parted from your money in that way. But it's yeah, it's a total scam. It's total junk science. Um, so that would be an example, of junk science. And unfortunately, there's a ton of it out there, and it's very hard to tell. Uh, it can be very hard to tell the difference between junk science and sound science, but it's really super important. And you guys are seeing this more and more now too. Uh, it's, well, with COVID and all the changes we're going through with that, and people trying to study it, it's super hard to tell what's the difference between junk science and sound science regarding COVID. And a lot of that difficulty too comes in the fact that since COVID is new, we don't know a lot about it. So as I talked about in an earlier video, the process of science isn't all neat and clean. Like it's kind of messy. Like you come up with ideas and then you test them and gather data, and then you draw conclusions based on that and go back and either modify your hypothesis, or you either accept it or reject it or modify it, and then test again and get more data. And it's not always this really nice, neatly packaged thing. Um, that process is still sound science. Unfortunately, junk science can look a lot like sound science sometimes, and sound science can be wrong occasionally. It's not. I shouldn't say sound science can be wrong. Uh, if you're doing sound science, sometimes hypotheses and stuff like that can be wrong, and that's okay if you're doing sound science. Um, so it can be difficult, all right? It's really super important though, so we know what to trust, and we know, um, because it's what we base our decisions. And again, going back to COVID, think about it. Like, people are basing very serious decisions on the evidence and science that's put out there. And if it's sound science versus junk science, you're like, people are basing decisions whether or not to get vaccines, get a vaccine for COVID. It's super important that you know the difference between junk science and sound science, and reliable, and how reliable it is. You're basing potentially literally a life or death decision, but at the very least an important health decision on that. Okay. All right. So let's look at some of the things, going back to the second page, that we can do for this. So when we're evaluating science, how can we help to determine whether or not it's sound or junk science? Well, they've got some basic questions on here. This isn't a comprehensive list by any means. There's obviously other things you can ask and more specific, but this is just sort of a general jumping off point. First, what are the observations or data underlying the conclusion? Can they be satisfactorily confirmed? And when you say satisfactorily confirmed, that means, have other scientists replicated the data? Have other scientists gotten the same results? Are they reliable observations? Did they have sound methodology when they did their tests and stuff like that, or did they not control variables, and is their test unreliable? All the type of things like that. Second one, do the explanations and theories follow logically from the data? Rationality. Okay, now and actually I don't have this on here. I'm gonna add this because this is sort of important too. A little surprised I don't have this on here, but okay. Two terms. One is correlation, and the other is causation. Now, what are these? Well, correlation is are events or occurrences, that type of thing, that are related in some manner. This could be, time, place, conditions, whatever, stuff like that. Okay. All right, what is causation? Causation is event that recurrence that leads to or causes the occurrence of another event. Okay. Causation is where one or a few things or whatever cause or lead to something else happening. All right. And one of our big problems is people confuse these two things all the time, and it leads to people drawing incorrect conclusions about things that happen. So, again, I use my hot button topic, my trigger topic a lot: vaccines. One of the popular sort of quote unquote evidence that people who believe vaccines cause autism give is these sort of anecdotal stories of somebody they know or somebody in their family or their kid or whatever. They were a perfectly healthy, happy baby, until they got their vaccines, and once they got their vaccines, a few weeks or a month later, they all of a sudden they turned from this perfectly happy, healthy, normal baby into they were showing all these signs of being autistic. Therefore, the vaccine caused the autism. Okay, they are creating a causal link, a causation event, when it's actually a correlation event. The signs of autism and the vaccines were correlated. In other words, they had some kind of relationship. They had some kind of relation or connection in terms of, and in that case, it would be in terms of time in the child's life. They both occurred around the same time. Okay. But there's no evidence and nothing that actually says that the vaccine caused the autism. Okay. There's been plenty of studies done and showed that basically, what a lot of people are seeing is that that's just the time in a child's life when it's different for all children, but a lot of times that's a time in life when autistic, what's the term I'm looking for, like traits start showing. Okay. Let me give you kind of a ridiculous example to help illustrate this. All right. So if if I'm at my house and I walk out the back door, I walk out my back door and I get struck by lightning. Okay. So I say, holy crap, like apparently walking out the back door of my house causes you to be struck by lightning. Like, no, everybody knows that's ridiculous. Okay, that's not walking out the back door has nothing to do with why I was struck by lightning. The two were correlated; they occurred in the same area at the same time, but they're not causal. Okay, like, oh, I better walk out the front door from now on, because if I walk out the back door, I'm gonna get, no, like everybody knows that's ridiculous, and that doesn't. But so I'm using that example to kind of show you like everybody understands that, but in other ones it's a lot harder to tell the difference. But it's a really important thing to understand the difference between correlation and actually proving and having data to show causation. Okay, hopefully that helps with the difference between those, which leads back to the question that we were looking at. Do the explanations and theories follow logically from the data? Is it rational? Okay, and that goes with the correlation and causation. Does the data actually show a causal effect? Okay. Third one, does the explanation account for all the observations? Objectivity. Is it objective? If the conclusion is logically inconsistent with any observations, it must be judged questionable at best. In other words, did they include all the observations in there? You can't cherry pick and leave things out that don't fit the idea or the theory that might contradict it. You've got to include everything in there. Now, that doesn't mean, sometimes there's observations that are, or sometimes there's data or observations that don't really fit the pattern. These are called, if you've ever heard the term outliers, okay? An outlier An outlier is a data point that doesn't really mesh with the others, and that's just usually seen as just kind of random chance, type of thing. It's not really indicative of the actual pattern. Take, for example, with the vaccine, the COVID vaccine, and people having severe allergic reactions. Okay. Were there cases of severe allergic reactions with the COVID vaccine? Yes, there definitely was. However, they were extremely minimal. I think at one point when I saw the data, it was like literally 11 cases in the United States, 11 total cases out of like 1.8 million or something vaccine doses given or something like that. Okay. So those are outliers. They don't exclude them from the data, but it's really not part of the overall pattern. It's a weird anomaly. Okay. So, but and that's okay to have outliers, but if somebody's not, like if they're excluding data from it, or if they are, ignoring larger chunks of data to sort of focus their conclusion and improve their conclusion in a way, that's very questionable. Okay. This one, are there reasons that a particular explanation is favored? This refers back to the bias, right? We already talked a lot about that, so I'm not going to explain a ton, but who profits or benefits from having that explanation accepted broadly, going to the bias type stuff, right? Okay. And then the last one, and by the way, just so you know, just if the answer to some of these is no, like that doesn't mean it's necessarily junk science. It just, like, you have to look into it more and sort of kind of take the totality of the information and judge it. Okay. Is the conclusion supported by the community of scientists with the greatest competence, that means like ability, to judge the work? If not, it is highly suspect. You see this a lot with climate change stuff. A lot of climate change deniers. There's some people who are scientists and other stuff like that, but to be honest, most climate change deniers aren't environmental or climate scientists. You get people from other areas of science or who aren't scientists at all. Deny the majority of. Now, you're never going to have 100% all people. I mean, you guys know this as well as I do. There's crazy people in every aspect of life. Okay, no matter what you do, no matter what career you're in, there are going to be crazy, whacked out people in that career. Okay, in that part of your life and what it is. So you're never going to get 100%. But do the vast majority of the scientists who are most knowledgeable and best able to judge the work agree on what it's saying? That's reliable and sound. Okay. All right. So that's just a little more information on kind of how to judge and figure stuff out. I believe that covers all of 1-2 then. I'm going to throw up the one homework assignment, and I'll make sure these notes get in with it as well. Okay. Have a great weekend. Got an extra day on Monday, and I will see hopefully, as far as I know so far, I will see B people on Tuesday and A people on Wednesday. Have a good one, guys.